Hello everyone and welcome back to Educator.com. I'm Dan Fullerton, and in this lesson we're going to talk about forces on current carrying wires. Our objectives include calculating the magnitude and direction of the force on a straight segment of current carrying wire in a uniform magnetic field, indicating the direction of magnetic forces on a current carrying loop of wire in a magnetic field, and determining how the loop will tend to rotate as a consequence of those forces, really starting to talk about rotation in electric motors, and finally, calculating the magnitude and direction of the torque experienced by a rectangular loop of wire carrying current in a magnetic field. Again, electric motors. So, let's start by talking about the basics of the forces on current carrying wires. Moving charges in magnetic fields experience magnetic forces. Current in wire, though, is just a flow of charges. Therefore, that wire is going to experience forces if they're moving in a mode that is perpendicular to the magnetic fields. So if we look down here at this drawing, let's assume we have current I here in black flowing in a wire, and we're going to break up this wire into little tiny pieces, dl, along the wire. And at any point in time, we have some small amount of charge, dq, at this section in the wire, moving with an instantaneous velocity v, as shown here in green. And all of this is happening in a magnetic field, where at this point, our magnetic field is here in blue, capital B. Well, in order to find the force, the magnetic force, what we're going to do is say that the magnetic force, FB, is equal to Q V cross B. But since we're only looking at a very little bit of charge, let's look at the tiny bit of force. The differential of the magnetic force then will be dq v cross b. That little bit of charge, its velocity crossed with the magnetic field at that point. This implies then that the magnetic force is, well, let's take a look here. If we think of it as current being equal to dq dt, dq we could write as I dt. So the magnetic force is equal to, we'll replace dq with I dt times v cross b. But we also know that v is dl dt. Therefore, v dt must be dl. So we can now write this as the differential of that magnetic force is equal to, we have our I, we have, well, v dt we said was going to be dl, so that will be dl crossed with b. Or, taking the integral to get the whole thing, the integral of dfb is going to be the integral of I dl crossed with b. The integral of the differential of the magnetic force is going to give you the entire magnetic force. So, to finish this up, the magnetic force is going to be the integral of the current times dl crossed with the magnetic field B. So that's how we can find the force on a current carrying wire due to a perpendicular magnetic field.